नमस्कार दोस्तों, welcome back to my channel VNP Networking Tutorials. In today's video, we are going to understand one of the most important concepts in BGP routing, the BGP split horizon rule. We will try to understand what the split horizon rule means, why it is required in iBGP, how it prevents routing loops, and I will try to explain the complete concept using the diagram shown on the screen. So let's get started. In this topology, we have total 3 routers, router R1, router R2 and router R3. All these 3 routers belong to the same autonomous system, that is AS 65000, and the routers are connected using iBGP session. You can see the iBGP neighbor relationship between router R1 and router R2, router R2 and router R3. Router R1 originates the network 10.10.10.0/24. You can see this network shown just below R1, the router R1. R1 advertises this route to router R2 using the iBGP session. That is why this green text says R2 learns the route 10.10.10.0/24 from router R1 via iBGP. So at this point, R2 successfully learns the route and the route is installed in the BGP table of R2. You can also see the small BGP table just below R2 router. The table shows network 10.10.10.0/24. The next stop is R1 and it's learned from iBGP. So far everything is normal till now. Now here comes the most important part. After learning the route from R1, R2 has another iBGP neighbor, that is with R3. Normally, you will expect that R2 to advertise the route to R3, but in iBGP, this does not happen. And this is exactly where the BGP split horizon rule comes into the picture. The BGP split horizon rule states that routes learned from one iBGP neighbor must never be advertised to another iBGP neighbor. So, because R2 learned the route from R1 through iBGP, R2 is not allowed to advertise the same route to R3. That is why you see the red cross mark, the red dotted arrow, and the message saying R2 will not advertise 10.10.10.0/24 to R3. As a result, R3 does not receive the route from R2. Now, the big question is, why does iBGP have this restriction? The answer is very simple: loop prevention. Without this rule, routes could continuously bounce between the iBGP neighbors or the routers and create a routing loops. For example, R1 sends the route to R2 and R2 sends it to R3. R3 may somehow send it back again to R2 and the route can circulate endlessly. Now this could create network instability, excessive routing updates, high CPU utilization, bandwidth wastage and slow convergence. So the split horizon rule prevents these problems. Now, this rule creates one important challenge. Since routers do not advertise iBGP learned routes to other iBGP peers, every iBGP router must establish a direct session with every other iBGP router. This is called as full mesh iBGP. For small networks, this is manageable, but in large enterprise or ISP networks, managing full mesh becomes very difficult because as routers increase, the number of iBGP sessions increases rapidly. To solve this scalability issue, network engineers use route reflectors or confederation. Route reflectors allow certain routers to redistribute iBGP routes to other iBGP peers. This removes the need for a complete full mesh, and confederation divide a large AS into small sub-AS internally. These methods improve scalability in large networks. In my upcoming videos, I will be covering route reflector and confederation separately with detailed explanations for each topic. I hope this explanation help you clearly understand the BGP split horizon rule in iBGP, and thanks for watching, and I will see you in the next video.